Good morning, students. Welcome to physics class. So, in last class, we have started the first chapter of your physics syllabus. We have started the first chapter, that is physical world. Physical world, which includes all the syllabus of 2-year science. Whatever you are going to study in these 2 years, that is first year science and second year science, all those topics are discussed briefly in this first chapter of PUC first year. That chapter is physical world. Physical world. So we have started this physical world with the word science. What is meant by science? With that we have started. The word science is taken from the Latin word scientia. Scientia. The meaning of this word is to know. To know. And the systematic study is called as science. After this, we have seen what are the steps or what are the methods involved in scientific method. What are the methods involved in scientific method? There are many methods you can adopt, but the important methods we were discussed, those are, first of all, systematic observation is very important. Systematic observation is important. After that, reasoning, calculation, predictions, falsification, verification, and finally you can write result. And in between this you can take mathematical modeling also. Modeling, experimenting, like this many methods you can use while studying about anything. About anything, that means whatever the phenomena takes place in the nature, about that if you want to study, then according to this scientific methods you have to do the study. After this we have come to physics. So physics is the word which is taken from the Greek word that is physis, F-U-S-I-S, physis. The meaning of this word physis is nature. And the exact definition of this science is the study which deals with matter and energy. It is a branch of science, obviously. Physics is a branch of science which deals with the study of matter and energy. Matter means whatever around us, whatever around us there, that is matter. It can be solid, liquid, gas, anything it may be. Then it is also defined in terms of science of measurements. Science of measurements. In physics we study about the things which can be measured. The things which cannot be measured, those are not studied in this subject called as physics. So physics is the branch of science which deals with the study of energy and matter, or it is also called as science of measurements. After this we have seen how this physics is divided. That means in earlier days, whatever this physics is there, this is very old subject. And whatever the subject this physics is there, whatever subject physics, the study of physics before 1900, the physics was called as classical physics. and the physics, the developed physics you can call. This is old. The physics which was discovered before 1900, that physics was called as classical physics. That physics was called as classical physics, and after 1900, whatever physics is there, that physics is called as modern physics. Modern physics, or it is also called as quantum physics, or it is also called as what? Quantum physics also it is called. So in classical physics, it is nothing but macroscopic. I already told you what is macroscopic, okay, word. It is related to macroscopic word, and it is related to, same again, microscopic. Same means not copy and paste. Okay, if it is macro, then it should be microscopic. Microscopic word. Once again I will tell, the physics which was discovered before 1900, that physics was called as classical physics. Classical physics, or it is also called as a macroscopic world. Macroscopic physics or macroscopic world. The physics which was discovered after 1900, that physics is called as modern physics. Name itself tells modern means recent. Modern means, okay, recent physics. That is modern physics. It is also called as I said, quantum physics, and this is also called as a microscopic physics or microscopic world. This is word important, micro. This is macro. Okay, so it is a big size, and here it is small size, Micro means very small size, and macro means it is very big size. Okay, big size in the sense universe, galaxies. Okay, so whatever the things are, okay, big in size. Okay, Earth, Moon, satellites, okay, planets. These comes under macroscopic world. Okay, because they are big in size. Okay, and here microscopic world means it is related to small size, means atoms, molecules, nucleus, nucleons, protons, neutrons, electrons, okay, positrons, quarks. Like this study comes under small size, and that is microscopic world. And whatever the study is there, that is modern physics. Whatever the development happened after 1900, that physics is modern physics. Here in microscopic, I have discussed thermodynamics, mechanics, heat, optics, electrodynamics. Okay, mechanics, it is related to motions. It may be any kind of motion. In a plane, 2-dimensional, 3-dimensional, in any plane, circular, straight line, any kind of motion we can study under mechanics. And in thermodynamics, we study about heat, temperature, hotness, coldness. About refrigerator we can study under thermodynamics itself. We can study about air conditioner, AC, in thermodynamics itself. And in optics we can study about lights. How light passes through different mediums. What are the phenomena takes place? Reflection takes place, or refraction takes place, dispersion takes place. Whatever this rainbow you can see, that is comes under this phenomena of light. After this, electrodynamics we discussed. Electrodynamics means it is related to charged particles. It is related to charged particles. When charged particle moves, it produces magnetic field. That's why it is called as electromagnetic induction also, or electrodynamics. Dynamics means it is moving. Electron, it is a charge. When electron moves, it produces current, and current produces magnetic field. That we can study under classical physics. And in modern physics, as I said, we can study about atoms, molecules, protons, neutrons, electrons, okay, antiparticles like positron, quarks, elementary particles are there, okay. So all this study comes under modern physics, So scope of physics we have discussed. The scope of physics is very vast. Okay, again, in thermodynamics, earlier there was steam engine was there. Little bit modifications according to the technology. It takes us to petrol engine, diesel engine, steam engine. Okay, steam engine was earlier used. Okay, nowadays petrol engine, diesel engines are used. These are all because of physics. Okay, the study of physics involved in this thermodynamics and in light also. Okay, and in optics, that is light and optics both are same. Like this, the scope of physics is very broad or very vast. And how this physics is useful to us? How physics and society? What is the relation between physics and society? Physics, because of physics, whatever the life we are enjoying, that is because of physics. That is because of technology, improved technologies of physics. Earlier people, they used to have very less facilities. Nowadays we have many facilities, and that is because of technology. Yes, in many ways this physics is useful. Okay, wireless communication, whatever you can see this video at your home, that is because of what? Because of technology. And technology comes from this physics. So like this physics is very useful to the society. Okay, because of this physics, our life become luxurious. It is not that much hurdles or difficult as our ancestors lived. Okay, we are enjoying this because of the technologies improving day by day, because of the physics. Okay, in every investment there will be physics. So this is the technology, society, and the physics. Technology, society, and physics. Next, we will move to the important concept, that is fundamental forces in nature. This is very important. Fundamental forces in nature, you can call. Very important question. Many times this question is asked. What are the fundamental forces in nature? They will ask. For 2 marks this question will come. So here, look at this word, force. I am applying force, that's why sound is coming. That's why sound is coming. If I stand like this only, if I not apply force on my lungs or this larynx, you cannot hear me. Okay, so I have to apply force for anything, any activity, any activity. Okay, so force, what is meant by force? You might have known. Okay, force and bala and okay. So force is nothing but pull or push. Pull or push. Okay. Pull means you have to, okay, take it out. Okay. Push means you have to, like this, you have to apply force. In both the cases you have to apply force. Pull or push is nothing but force. Is nothing but force. And the correct definition of force was given by Isaac Newton. Isaac Newton, very great scientist in physics. Isaac Newton. So he given the correct definition of force at first. According to Newton, what is force? Pull or push. Pull or push is called as force. Is called as force. So here, basic forces. Okay, fundamental, or it is also called as what? Basic forces. Okay, fundamental, or it is also called as what? Basic. Okay, basic force. So here in nature we have four fundamental forces. We have four fundamental forces. Those are, first one, right? Gravitational force. Gravitational force. Second one, electromagnetic force. Electromagnetic force. Third one, strong nuclear force. Strong nuclear force. And final, fourth one, weak nuclear force. Weak nuclear force. So see here, these are very important four forces which we can get in the nature. First one is gravitational force. First one is gravitational force. Second one is electromagnetic force. Third one is strong nuclear force. And fourth one is weak nuclear force. These are the four fundamental or four basic forces in nature. Very important question. Again and again I am telling this. They may ask for 2 marks. Write 2 fundamental forces in nature. Write 2 fundamental forces in nature. Then you can write any 2 of this. Instead of writing 4, you would write any 2. You would write any 2 out of 4. Out of 4. So very easy. First one is gravitational force. Second one is electromagnetic force. Third one is strong nuclear force. And fourth one is weak nuclear force. Fourth one is weak nuclear force. Correct. Then next, they may ask here, what are the, which is the strongest and which is the weakest force in nature? Which is strongest force and which is weakest force in nature? They may ask. Okay. So here, gravitational force. Already we are going to study this in gravitational chapter, but I will tell what is meant by this gravitational force. This gravitational force is attractive force. It is attractive force. Attractive force. So whatever apple fall on the earth, that is because of what? Gravitational force. Apple falls on the earth, that is because of gravitational force. And here attraction between this apple and earth takes place. Because of this attraction, this apple comes towards the earth, Now whatever this chalk piece is there, if I leave this chalk piece, it will come down to the earth. This come down to earth because of which force? Because of which force? Gravitational force. It is what? Attractive. It is what? Attractive force. It is attractive force, and it has infinite range. Infinite range. Infinite range. If you go several kilometers away from earth, even though gravitational force will be there, so whatever the planets revolving around the sun, whatever planets are there, those are revolving around sun because of gravitational force. This gravitational force takes place in two objects or two masses. If two masses are there, then these two masses will attract each other towards each other. Okay, that is what? Gravitational force. The force is called as what? Gravitational force, and it is always attractive force in nature. And the range of that force is infinite. Okay, it is not limited. The force is not limited to this area or this much area or this much area. It is related to infinite area. We cannot measure that area. Okay, so the range of that gravitational force is infinite. Correct? So this is what? Gravitational force, and it is weakest force in nature. Okay, here you can write weakest force in nature. Weakest force. Okay, keep in mind which is the weakest force in nature. Gravitational force is weakest force in nature. Correct? Second one, electromagnetic force. Okay, so here electric field is also there and magnetic field also there. That means here electromagnetic force takes place in charged particles. Okay, this is charged particles. Electromagnetic force takes place in charged particles. Okay, it may be attractive or repulsive. It may be attractive or repulsive. Correct? It may be attractive or repulsive. And here, so here charged particle. So here we know already there are two kinds of charged particles, positive and negative. Okay, suppose here positive and positive are there. They will repel. Suppose one is negative and one is positive is there, then they will attract. Okay, positive, negative, they will attract, and positive they will repel. Okay, so that's why this electromagnetic force is attractive or repulsive. Depend on the nature of that charge. Okay, if it is again negative, you can take here negative. It is also repulsive. Okay, So strong nuclear force. Strong nuclear force. It is strong nuclear force means it occurs in nuclear reactions. It occurs in nuclear reactions. Okay, and it is strongest force in nature. Strongest force. This is strongest force in nature. Okay, remember this. The strongest force in nature is strong nuclear force. Strong nuclear force. And which is weakest force? Gravitational force is weakest force. And which is stronger? Strong nuclear force is strongest force. Okay, it is about 10 raised to 39 times 10 raised to 39 times greater. Okay, times greater than gravitational force. Just you imagine. Okay, and the range of this strong nuclear force is very small. The range of this strong nuclear force is very small. That means you can take it as 10 raised to minus 14 meter, 10 raised to minus 15 meter. Okay, in this range only the force will takes place. Okay, so this is which force? Strong nuclear force. It is strongest force in nature, and it is approximately how much times? 10 raised to 39 times greater. 10 raised to 39 times greater than gravitational force. 10 raised to 39 times greater than gravitational force. That means what? Gravitational force is 10 raised to 39 times weaker than this strong nuclear force. Strong nuclear force. Right? And last one is that this is weak nuclear force. Don't go on this name, weak. Okay, weak nuclear force is weak force in nature. No. Okay, don't get confused. The weakest force is which one? Gravitational force. Sorry. The strongest force is strong nuclear force, and weakest is gravitational force. Don't write weakest force is weak nuclear force. This is wrong. Okay, so weak nuclear force, it occurs in again nuclear reactions. Nuclear reactions like beta decay. You are going to study this in second year. Okay, so don't get confused here. So weak nuclear force, again it is also small range force. Okay, the range of this force is very small. That is around 10 raised to minus 16 meter. 10 raised to minus 16 meters. Like that. Approximately I am telling. Okay, approximately, it is not exact. Okay, range of this nuclear force is 10 raised to minus 16 meter, and this strong nuclear force is approximately 10 raised to minus 15 meter. You can confirm this with your books. Okay, it may get changed. Okay, don't go on numbers. So weak nuclear force occurs in beta decay. Okay, process. Beta decay. Words are very different. You may not understand in first listening. Okay, so for that purpose you have to listen this again and again, and you search the meaning of these words in dictionary. You should have the habit to see the unknown words or unknown words meaning in your dictionary. So you carry one pocket dictionary. Nowadays it is not necessary because many applications are there, softwares are there. You can download it and you can check the meaning of what is beta decay, what is nuclear force, like this. Okay, so this whatever nuclear forces are there, these nuclear forces are present in atoms, protons, neutrons at the nucleus. Nuclear means, okay, the force which is present in nucleus. In nucleus, protons and neutrons will be there. Protons and neutrons are there. To hold these protons and neutrons, one force is required. That force is nuclear force. That force is nuclear force. And this force is very strong. Very strong. How much strong? It is strongest force in nature. It is strongest force in nature. So these are fundamental forces in nature. First one is gravitational force. Second one is electromagnetic force. Third one is strong nuclear force, and fourth one is weak nuclear force. Weak nuclear force. Don't forget this. It is 99%. This question will come to your exams. Many times this is asked. If you open the previous year question papers, this question is common. This question is common. They may ask, write strongest and weakest force in nature. Strongest and weakest. Strongest means you write third one. First, strong nuclear force. Second one, you write gravitational force. Strongest force, strong nuclear force. Weakest force, gravitational force. These two you write. Sometimes they ask, write any two basic forces in nature. Write any two. In that case also you can write these two or any, whichever you feel easy, that you can write. Okay, strong nuclear force, weak nuclear force. In that case you can write. If they have not mentioned strongest and weakest forces in nature. If they mention strongest and weakest force, then you write strong nuclear force and gravitational force. Then only you will get the marks. Otherwise, no. Okay, I hope it is clear to you. Next, we will move to next we will see laws. Okay, laws in physics. Laws in physics, there is conservation laws. Conservation, the new word again. Conservation laws in nature. Okay, conserve means constant. The meaning of conserve means constant, or it is which does not change. Does not change. In nature or universe, some quantities are there. In nature or universe, some quantities are there which does not change. Which does not change. That means they remain as it is. They remain as it is. There will be no change. There will be no change. Such quantities are called as conserved quantities. Such quantities are called as conserved quantities. Conserved quantity. Such quantities are called as conserved quantities. What is meant by conserved quantities? The quantities which does not change. Okay, the quantities which does not change are called as conserved quantities. Conserved quantities. And the law which governs these quantities. The law which governs these quantities is called as conservation laws. It is called as what? Conservation laws. Correct? The law which governs conserved quantities is called as conservation laws. Conservation laws. Okay. So conservation means what? Which does not change or which is always constant. Constant means does not change. Its value never changes. Such quantities are called as conserved quantities. Such quantities are called as conserved quantities. And the law, here we can write the law which governs conserved quantities, conserved quantities are called directly you can write this, are called conservation laws. What is conservation law? The law which governs conserved quantities is called conservation laws. Okay, or here you can write is also, no problem. Okay, the law which governs conserved quantities is called conservation law, is called as conservation laws. What are conserved quantities? The quantities which does not change. Here conserved quantities means what? The quantities which does not change. These quantities are called as conserved quantities. The law which defines this, these conserved quantities, that law is called as conservation law. That law is called as what? Conservation law. Example for this conservation laws, here we can write conservation law. Example, we write conservation of law of conservation of energy. You know already this. Law of conservation of energy. Law of conservation of energy. Already you know this. Energy can neither be created nor be destroyed. It can be converted into one form to other form. This is what? Law of conservation of energy. That means potential energy plus kinetic energy is equal to total energy, and that is always constant. Second one, we can write law of conservation of linear momentum. You will study this. P is equal to mp, mass into velocity, is called as linear momentum. Like that. Third one, law of conservation of angular momentum. Law of conservation of linear momentum. Next, law of conservation of angular momentum. I have not written here. Okay, law here. You can consider this. Okay. Fourth one, law of conservation of charge. Here we cannot create charge, or we cannot destroy. Just we can transfer it to one body to other body. Like this, laws will come. These laws are nothing but conservation laws. First one is what? Law of conservation of energy. Second one, law of conservation of linear momentum. Third one is law of conservation of angular momentum. Like that, law of conservation of charges. Okay, like this, many laws are there. So this is just recap of that. This is just highlight of conservation laws. You can write, if you know the different examples, you can write here also. No problem. Okay. Next, after this, some discoveries are there. What are the discoveries taken place in physics? For that purpose, we have made one table. One side we have made scientists, and one side we have made their contribution or discovery. Scientist, discovery. Correct. Newton, here gravitational force, like that. Galileo, law of inertia, and he discovered telescope also, like that. Boyle, okay, Boyle's law of gases. Carnot, heat engine. Carnot is a scientist and heat engine is his discovery. So what I will do to this video, or after this video, I will give you one photocopy of those discoveries in physics. So this is all about the first chapter, that is physical world. We have studied physical world, and this is the end of the first chapter. It is very simple and short topic. It is very short topic which comes for 2 marks. It may sometimes come for 3 marks also. Correct? So here one more question will come. Who discovered electron? Who discovered electron? So here electron is a discovery, and one side you write the name of the inventor. Who discovered? So here J.J. Thomson. J.J. Thomson discovered electron. Like this you write. Like that you write. Raman effect. Who discovered Raman effect? Then you write C.V. Raman discovered Raman effect. Like that you write. Who discovered electric current? So in that case you write Ampere. Ampere, like that. Who discovered motor? Electric motor? Then you write Faraday. Michael Faraday. Like this many scientists will come. I will send the important discoveries in physics after this video. You see that and you can make copy of this. So this is all about the first chapter, physical world. We will start the new chapter in next class. Prepare well, stay safe. Thank you.